Hello everyone, welcome back from my channel. Today we are going to do the exercises from Cambridge Primary Science Workbook 5. 5.5 Magnets and Magnetic Materials. Focus. Question number 1. Tick yes if the object is made of magnetic material. Tick no if the object is made of non-magnetic material. Cast iron pot. Yes. Rubber gloves. No. Wooden spoon. No. Wool. No. Steel paperclip. Yes. Plastic bottle. No. Aluminium pot. No. Gold rings. No. Rubber tire. No. Plastic bucket. No. Brass candlestick. No. Iron nails. Yes. Question number 2. Your grandma drops a box of pins on the floor. A. Describe how you could help her pick the pins up easily using a magnet. Hold the magnet above the pins and they will be attracted to the magnet. Question B. Why does the magnet pick up the pins? The pins are made of steel, which is a magnetic material. The magnet attracts the magnetic material. Question 3. There is a mixture of iron nails and wood shavings on the floor of the workshop. A. How can you get the nails out using a magnet? Hold the magnet above the nails and wood shavings. The nails will be attracted to the magnet. The wood shavings will not be attracted to the magnet. Question B. Why does the magnet pick up the nails? The nails are made of iron, which is a magnetic material. The magnet attracts the magnetic material. Question C. Why doesn't the magnet pick up the wood shavings? Wood is not a magnetic material, so the magnet does not attract the wood shavings. Challenge. A compass has a magnetic pointer or needle that is attracted to the Earth's magnetic north pole. Sarah and Sophia decided to make a simple compass. They used a polystyrene cup and some water, a cork, a sheet of A4 paper, and a pen, a bar magnet, a large steel needle, a small piece of sticky tape, and some steel pins. Here are the steps they took to make the compass. They wrote the points of the compass: N for north, S for south, E for east, and W for west at the edges of the A4 paper. They place a paper on a flat surface far away from any metal object. They put a little water in the cup. They place a cup in the middle of the paper. They stuck the needle to the table with a small piece of sticky tape. They struck the needle with one pole of the bar magnet. They struck in the same direction too and made sure the bar magnet was well clear of the needle at the end of each stroke. They continued stroking for about 5 minutes. Then they tested to see if the needle was magnetic by trying to pick up paper clips with it. They pushed the needle through the cork and floated it in the water in the cup. They turned the cup until the needle was lined up north, south on the paper. The needle stayed pointed north because it was attracted to the Earth's north pole. Question 4. Why did they use a steel needle to make the compass? Because steel can be magnetized. Question 5. Why did they stroke the needle with a magnet? To magnetize the steel needle. Question 6. Why did they test the needle by trying to pick up pins with it? Paper clips are metal and will be attracted to a magnet. Question 7. Why did they use a cork to stick the needle through? Cork is a non-magnetic material. Question 8. Why did they use a polystyrene cup for the water? Polystyrene is a non-magnetic material. Question 9. Why did they put the compass far from any metal object? So that it would not be attracted to anything except the Earth's magnetic north pole. 5.6 Magnetic force. Focus. Aaron and Marcus have two bar magnets. They did an investigation to find out which magnet was strongest. They used a plastic ruler and metal paperclip to compare the distance each magnet could attract the paperclip. Here is a table of their results. Question number 1. Complete the table by filling in the average or mean readings. Question 2. Why did they make 3 readings for each pole of each magnet? To get more accurate results. Question 3. Why did they use a metal paperclip and not a plastic-coated paperclip? A metal paperclip is magnetic, so it is attracted to a magnet. A plastic paperclip is non-magnetic, so it is not attracted to a magnet. Question 4. Which magnet was the strongest, magnet 1 or magnet 2? Magnet 2. Question 5. Which pole of the magnet was strongest, the north or the south pole? South pole. Question 6. What conclusion did Aaron and Marcus make about the strength of magnets? Magnets have different strengths. The poles of one magnet can have different strengths. Practice. Marcus compares the strength of 2 bar magnets A and B. He has 3 pieces of cut, 10 cm, and a stick screw. This is what Marcus does. Step 1. Marcus places the screw on a table underneath one piece of cut. He holds magnet A over the cut. The screw sticks to the cut and he is able to pick up the cut and screw with the magnet. He repeats step 1 with magnet B and gets the same result. Step 2. He now puts 2 pieces of cut between the magnet and the screw. The screw sticks to the magnet through 2 pieces of cut when he uses magnet A and magnet B. Step 3. He now puts 3 pieces of cut between the magnet and the screw. The screw sticks to the magnet through 3 pieces of cut when he uses magnet A. But when he uses magnet B, the screw does not stick to the cut. Question 7. Why does the screw stick to the cut when Marcus holds a magnet over the cut? The screw is made of steel, which is a magnetic material. Question 8. Which magnet was strongest, A or B? Explain why. Magnet A, because the screw stays stuck to the back of 3 cuts. Question 9. List 2 ways that Marcus' experiment was a fair test. He used the same size screw made of the same material for each magnet. He used the same size and thickness of cut for each magnet. Question 10. Could Marcus have used a cork or a plastic button instead of a screw to test the strength of the magnets? Explain why or why not. No, cork and plastic are non-magnetic materials, so they would not be attracted to the magnet. Challenge. MAGLEV stands for magnetic levitation. Levitation means floating above the ground. Magnets on the track push and lift the train up in the air by 3 to 15 cm. So, a maglev train floats above the tracks on a cushion of magnetic force. The magnets in the track are extremely strong and very expensive. If a country wants to use a maglev train, they have to build a completely new magnetic track. It is not possible to change an old train track into a maglev train track. Maglev trains float on air. This means there is no friction with the track. This lack of friction allows these trains to reach speeds of more than 500 km per hour. Maglev trains have no wheels. This makes them quieter than normal trains. Maglev trains use 30% less energy than normal trains. Question 11. What are maglev train tracks made of? Maglev train tracks are made of magnets. Question 12. What keeps a maglev train moving 3 to 15 cm above the track? Magnetic force. Question 13. Give 3 advantages of the maglev train compared to a train that runs on metal tracks. Maglev trains travel faster. They are quieter. They use 30% less fuel than normal trains. Question 14. What is the main disadvantage of the maglev train? It is very expensive to build the tracks. Question 15. Find out which countries use maglev trains. In 2020, there were 2 maglev trains in use in China, 2 in South Korea, and 1 in Japan.